Hi, I'm Andrew with eGauge Technical Support, and today we're outside of eGauge HQ getting ready to install an EG3010 into this panel. We've already removed the front of the panel, added a new breaker in here to power the eGauge. We're going to install the eGauge up here in the top corner, connect the eGauge to this breaker using a power whip, and then put CTs on a couple of conductors in the panel so we can get a reading on what's happening. This is an EG3010. It's got a 5-pin power plug on the bottom for incoming voltage connections, 12 CT ports along the side for current transformers, and an Ethernet port, which will remain capped off. There's also a status LED on the front of the unit that'll tell you the operating conditions based on what's happening with the device. Since the EG3010 and the EG3000 are indistinguishable from one another, you should always check the sticker on the back for the model number of the device that you're using. For this install, we'll just be bolting the eGauge directly to the back of the panel. For this, we're using a couple self-tapping screws and a standard screwdriver. This is the eGauge power whip. This comes pre-assembled with wiring for 3-phase following North American color coding standards. 3 hot phases, 1 neutral. The ends are sealed with epoxy, so there's no risk of electrocution from this end. And the whip is typically about 8 feet long, so you've got a lot of wire to play with. Since this panel is a split-phase application, we'll just be using our 2 hot phases, the red and black wires, along with the neutral. We have no need for that 3rd phase, that blue wire. So we're going to go ahead and connect this 5-pin power plug to the base of the eGauge. I'm going to go ahead and just cut the blue wire right away. We don't need that at all. So we'll cut that as close to the 5-pin plug as we can get it. That can always be tidied up later if need be. Our red and our black wires are going to run down to this breaker here. We're going to use this top one, so we really only need about 8 inches of wire. So we'll go ahead and mark that off. Cut these as well. And then we'll strip them. And we'll go ahead and get those in the breaker. And then our neutral is actually going to run all the way down the base of the panel, around and up to the top to our neutral bar on this side. So just a quick test run to see how much length we need. That looks about right. We'll go ahead and trim off the excess here. And we'll strip it with our strippers. And we'll feed it into this neutral hole here. And we'll just make sure this is nicely tucked around the bottom of the panel when we're done. Next, we're going to install our current transformers, or CTs. CTs go around a conductor in your panel and take a reading from that conductor back to the eGauge that lets you know how much amperage is flowing through the conductor. These CTs are hinged, so they open up across the top like this, and they get wrapped around the conductors, typically for the main feeds coming in, and for the sources of generation, which is going to be this breaker down here. There's a couple of things to keep in mind when looking at these CTs, because there are several varieties. All the information you need is contained on the sticker on the front. So that'll have the manufacturer of the CT, the internal diameter of the CT, which is the diameter of the largest wire that could pass through it, and the maximum amperage that the CT can read. There's also a sticker on the side that indicates the direction of current flow. For that, we want to point that arrow on that sticker towards the item being measured. So up towards the utility meter on this section. On the solar side, towards the inverter. The CTs we sell have about 6 feet of twisted pair wiring and a 2-pin plug that matches up to the eGauge. This plug can be removed and the wiring extended or shortened as needed for your installation. A little extra wiring isn't going to hurt. You can just tuck it to the side in the panel wherever there's room. First, we're going to install our CTs on the main utility feeds up here at the top of the panel. Each conductor gets its own CT, and the CTs need to be oriented in the same direction. We're using these 100 amp CTs, and you can tell by the sticker. We're going to make sure that the arrow is oriented facing towards the utility. Just get that clamped in place, squeeze it until it's fully engaged, and then check to make sure you've got full engagement there. We're going to do the same thing on this conductor as well. Make sure it's fully clamped down, arrows in the correct direction. So we're also going to install a 50 amp CT down here on our solar conductor. Just gets clipped into place. And then we'll undo this wiring and run it up to the top of the panel. Next, we just have to connect the CTs to the eGauge using the 2-pin plugs. The ports that you connect to are completely arbitrary. You just need to make a note of which ones you use. For this one, we're going to use port 10 for our solar CT, port 11 for our red phase or A phase CT, and port 12 for our black or B phase main CT. So at this point, we're pretty much done. All we need to do is clean up a little bit with our wiring here, get that tucked back into place. We'll go inside, get the home plug adapter connected to the eGauge, put the panel front back on, and be good to go. For our final step, we're going to install our home plug adapter. This goes directly into a wall outlet, and then an Ethernet cable connects the home plug adapter to your router. The top LED will be lit up solid when the home plug is connected to a wall outlet. The bottom two will flicker as data is transferred between the home plug and the eGauge. For more information on pairing, phasing, or any other questions, see the links in our video description.